Is it visible?
Yes, sir.
Okay. So today we are going to talk about a few of the Verilog topics, which are very basic but very tricky questions. And there is a logic behind every question. And most of these questions are asked in all entry-level interviews. I mean all, because they are very logical questions. So let's start. So our first is, okay, so there are different type of operators in Verilog, right? You might be aware that multiplication operator, AND operator, OR operator, then equality operator. So just like that, there are two operators. One is negation and the other one is the invert operator, right? These are generally confusing that both operators revert the value. If I give this as 1, this will also return me 0. And if I give this 1, this will also return me 0. So let's understand this one. Now, we are declared a wire as enable, right? We are assigning a 1 to it. Now, in an initial block, we are negating this value using this negation operator, right? So, is any idea what is this going to return? Negation enable? Any guess?
0.
0. Any other? Anyone saying 1? No. Okay. Negation operator generally deals as a logical operator. So it evaluates the condition whether it is a true or a false. So now 1 will be considered as true because this is a non-zero value, right? So negation operator will consider this as true. Okay. So what is the invert of true? What is the opposite of true? False, right? And false will be treated as 0. So this becomes 0. Now, which display will come? True or false? Any idea, guys? The condition inside this block is 0. So whether we will get this display?
No, it goes to false. It goes to false.
Right. So this is 0. This will go into else condition. Go into false condition. Okay. Now let's try this invert operator. So okay. Enable is 1. If I invert this, so invert operator generally work as a bitwise invert. If you give this as a 1-bit value, it will invert it. If you give it as a 5-bit value, it will invert each and every bit. So, but in this case, since there is only single bit, right? 1 is a single bit. What will be the opposite of 1? Like invert of 1 in 0.
0.
Right? So we will again get into else loop and we will get a false here. But let's see when this is a multi-bit signal. So now enable is a 2-bit. That is 0 and 1, right? So as I mentioned earlier, negation operator deals as a logical one. So when this is works as a logical, 0, 1 is actually true value because this is a non-zero value and every non-zero value is treated as 0. This is true, but negation operator will change it into false, right? And again, because this is false condition, we will jump into else block, that is false. So in this case, we will get false. But let's try invert operator. Invert is a bitwise operator, right? So our actual value is 0, 1. So now this will invert each and every bit. So 0 will be inverted as 1 and 1 will be inverted as 0, right? Now this becomes
true.
And 2 is a non-zero value. It will be treated as
true.
So in this case, we will get this display. This display, right?
Yes.
Now, if I ask you guys a question, that is, let's take a 4-bit signal, okay? So this is my signal. Okay, if I do of this, what will I get?
0, sir.
0. Okay, and if I do like this, in this case, what will I get?
Still 0.
Sorry, what? So remember that this is a negation operator, and this will deal as a logical. It evaluates the condition as true or false.
It evaluates to false and give it as 0. Evaluates to false and give it as 0.
Correct. Because this is a non-zero value, right? It cares about whether this is a true condition or false condition. So this acts as a true condition, and it changes this to 0, which is false. Now, if we use this operator here, what is the expected value?
So 0, 0,
0, 0,
and 1, 0, 1, 0.
1, 0, 1,
1, 0, 1, 0.
True value.
Any other answers? Yeah, this is the correct answer because each bit is inverted. 0 changes to 1, 1 changes to 0, 0 to 1, and 1 to 0. Right? Okay. So yeah, summary is that negate operator deals as a logical negate operator. It evaluates as whether the condition is true or false, whereas invert acts as a bitwise operator, and it deals in inverting each bit. Let's check the next example. Very basic but very important. Blocking, non-blocking, right? So this is a representation of a blocking assignment equals to, and this represents a non-blocking assignment less than equals to, right? So how many regions we have in Verilog? Anyone?
How many?
Regions.
4 regions.
4
Okay, 4 regions. What is the first region?
Active region.
Okay. Second one.
Inactive region.
Okay, nice. Third.
Non-blocking region.
non-blocking assignment region,
Correct. Fourth one is
monitor region,
Postpone region.
correct.
postponed.
Okay. Now, in which region this blocking assignment works?
Active region.
Active region.
Correct. Now, this, so for example, so this is 0, but let me change this to 2 is equals to A plus B, right? Now, A plus B is a right hand side and Q is our left hand side. So, in which region this will be calculated? So, this has to be calculated, right, by simulator, because A is one value, B is one value, and A plus B simulator will do. In which region simulator will calculate this value? And out of these 4, which region simulator will start calculating this value? It will check what is A, it will check what is B, and it will plus them.
Active region.
Active region, yes. So this right hand side is calculated in active region. Now simulator need to assign this value to Q.
Q.
Right? It calculated this. For example, it calculates this as 1 plus 2 and it gets 3. Now in which region it will assign this?
Active region, sir.
Active region, yes. So value will be evaluated in active region and assigned in active region. Let's talk about non-blocking now. So again we have A plus B, right? So now in which region it will calculate this A plus B?
Active region, sir.
Active region. And in which region it will assign this to Q?
Non-blocking region.
No. Inactive.
Okay, one answer is, let me write it here. That is, let me mark this as 2. So 2 represents inactive. Okay, inactive.
Non-blocking.
Okay, one is saying non-blocking. Any other? Yeah, non-blocking. That is why we have a special region for this. So it will calculate this, the same region that is active. So if we look at the value will be 3 in both the cases. Value will be 3, it will not assign immediately. It will hold this value. It will save that, okay, a plus b is 3, but I am not going to assign right now. I will execute all the things which are present in active. I will execute if there are any things in inactive. In non-blocking, I'm pick this value 3 and will assign to Q. Okay. So by the way, what are the different? I mean, what is executed in inactive region? So we checked this in active region. I mean, calculation happens right inside for blocking and non-blocking. And also dollar displays are also executed in this region, right? What is executed in inactive region?
Zero delay statement.
Right. So zero delay statement that are represented as #0. And then in non-blocking, assignment happens. Assignment for non-blocking assignment, non-blocking statements. And what happens in postpone region?
$monitor and $stop.
Right, $stop, also $monitor. Okay. Okay. This is clear. Any questions in this? Okay, I will take that as a no. Okay. One general question: what is the difference between display, $display, and $monitor?
So display just like provides the value. What if you have implemented A, it provides the value of the latest value of A, but monitor will show like all the changes of the A which was made previously also.
Yes.
Hello.
Yes.
Yes, sir. Hello.
You are audible.
And display provide the value, anything latest value, but monitor whatever value you are changing, that is display.
Okay. So, for example, if I'm not changing any value, for example, there is a variable A. A is always 0. So, what will $monitor print?
It will just print 0, sir. 0, sir.
0. And the thing is, $display will print which are value present in active region because it executes in active region. Right? So if there is any assignment, for example, this assignment will happen in non-blocking, right? But your $display will still print it as, for example, in this case, it is calculated, but let us take one example here, right? What is the value of Q in active region?
3.
What is the value of, suppose initial value is of Q is 0. So what is, if I check using $display, what will the value, what will $display will print of Q? If I say that $display and print me, so what this will return? That Q is having
It's default values, no?
Default value. And I said like earlier, default value is 0. And in active region, what it will print? Because after active, there is inactive, right?
It will print 3, sir.
It will print 3. Okay. Any other answers?
Still 0,
Default
sir.
value 3, X, Z. Any? Okay. All agreeing with 3. Actually, it will print 0 because this assignment simulator is still holding this 3. It has decided to assign to Q non-blocking region, right? non-blocking, and non-blocking region is yet to come. When I use if I use a monitor here, monitor will print me 3 because monitor will be executed in postpone region. And in postpone region, non-blocking assignment already happened. Right? So $monitor will give me, if I type it here as Q, then this will give me 3. Okay. Any questions on this? Okay, I'll take that as no. Okay, yes, very important. So synchronous and asynchronous flip-flops, right? So we have multiple flip-flops like D, E, JK, SR, and then there are 2 types of them, synchronous and asynchronous. Anyone knows before we start what is difference between a synchronous and asynchronous?
Asynchronous means like irrespective of the clock, it works. Like if you give as a reset high, irrespective of what is
clock will be
the
given.
clock value, it'll automatically change to 0. That is
When same
asynchronous.
clock is given to all the flip-flop, then it's called synchronous. Different clock is synchronous.
Okay.
There is a dependent clock. Asynchronous is independent of clock.
No, sorry. As far as I heard, so he says one depends on clock and the other one.
Synchronous is dependent on clock. Asynchronous is independent of clock.
Okay, one is dependent. Synchronous is dependent of clock, and asynchronous is not dependent on clock. Huh?
Yes.
No, sir. Both are dependent on clock.
Two are dependent on
In
clock.
synchronous,
Same
in
clock.
Synchronous we can give synchronous we can give simultaneously clocks. Sir, in asynchronous we can't give simultaneously clocks.
Okay, let's understand this. Okay, so which one is? So this is a Verilog code for synchronous and asynchronous. So which one is synchronous? Which one is this?
Right one is
Right side is synchronous.
right side is
Right side is synchronous. Okay, and this one is asynchronous. Correct?
Yes.
yes, sir.
Let's see synchronous one. So synchronous means it is dependent on clock. This is also dependent on clock, right? So if we look at the code, this is a always block, usage of clock. We can write negage as well, but in this case, this is a positive as triggered. So this block, always block will be triggered whenever the simulator sees a positive edge of a clock, right? So now let's start from here. Clock is 0, 0, 0, right? Nothing happens. Here, it sees a positive edge. Now this code, this always block got triggered that, okay, there is a positive edge. Now let's go inside this now. If reset is high, what is the value at this positive edge of clock?
What?
1 means reset is high, right?
Yes, sir.
Reset is high, it means code is saying that assign 0 to Q. So Q is assigned to 0, right? Now let's go to next clock. So again, there is a positive edge, right? So this code triggered again. What is the value of reset here?
1.
At this positive edge.
Yeah, it's high.
0.
0.
0.
It's low, and low means 0. It's 0.
0.
It went to else block. It means assign D to Q. Whatever the value, D is high, right? D value is assigned here.
High. 1.
Correct. Yeah. So, and before simulation, values remains X because this Q is the register, right? And what is the default value of register?
1.
What is the default value of register?
X.
0.
X is the default value of
Once.
register. X, it is X.
0.
Okay, default value of register. Here Q is, one is saying it's X, one is saying 0. Okay.
Sir, it's X.
Huh?
0, sir. 0, sir.
Okay. It's actually X.
X.
Yeah, that is the default value of a register, because if we are not initializing it to any value like 0 or 1, so it will hold a X. Now, what is the default value of wire?
Sir, Z.
Zero.
Z.
Z, sir.
Z.
Z.
Okay, one is saying Z, 0. Okay. It's actually Z. So these two are very important to remember, right? Default value of wire is high impedance, Z is Z, and default value of a resistor is X. Okay. So this is the functioning of a synchronous. If you have noticed here that reset is going high here, right? See, reset is going from low to high, but nothing is happening in the code. Because my code is looking for a positive edge of a clock. It doesn't care what reset is until there is a usage of clock. But let's check asynchronous now. In asynchronous, my code says that whether there is a positive edge of a clock or there is a positive edge of reset. So when I checked this, okay, there is no positive edge of a clock. There is a positive edge of a reset. This code got triggered. Now, because of there is a positive edge of a reset here, let's enter into this code. Reset is high. Reset is high here.
Yes, it's high.
It's high, right? So this value will be 0 to be assigned to Q. So this is Q and 0 is assigned to Q. Before simulation, value was default, that is X. Now let's check at next clock. So okay, now we are having a positive edge of a clock. Okay, this positive edge of a clock again got triggered. If you see, there is only a positive edge of clock. There is no positive edge of a reset. Reset remains high. This code again got triggered. So this got triggered. What is the value of reset at this clock? 5.
0. 0.
High.
0.
It's 1.
Reset
No,
is high and output is 0.
Output is 0, right? And at next clock cycle, reset is 0 and output is 1. Now, let's summarize this. Summarize this in a way that asynchronous gives a high priority to reset, right? Asynchronous is giving priority to reset, right? Because in this code, reset was having a trigger, positive edge, but my code doesn't care. It only cares about a clock. But asynchronous also gives priority to reset as well. Okay. Any questions in this?
Yes, sir. I have one doubt.
Okay.
Sir, in asynchronous, this always block depend on a positive edge of clock or positive edge of reset.
Right. It means it is looking for a positive edge or a positive edge of reset. If both are coming good, one is coming good. If both of them are not coming, this code will not be triggered. So in this T3, this condition got satisfied because this is a positive edge in reset. So this block triggered at T3 also. At T5, block got a positive edge, so this got triggered at T5. But in this case, this code does not trigger on T3 because it is only looking for a positive edge in clock. Okay, so if I say this is 1, this is A, and this is B, either A can happen, or B can happen, or both can happen. At that time, this code will trigger, and basically it will function.
So here the reset goes low no in asynchronous before the second passage of clock. Then here the Q also must go high whenever the reset goes low, no sir, here before the clock comes.
No, could you repeat? Is there any scenario like this in T3, T5, T15 or T25?
In T5 to T15, there is a reset goes low in asynchronous.
Okay.
So then
Okay.
the Q must go high before the clock edge, no sir? It will
No. If your reset is going low, this code is not looking for a low. When a signal goes from high to low, it is called as a negative edge, right? But your code is a positive edge flip-flop.
Yes, sir.
When this is going low, nothing will happen.
Yes, sir.
Nothing will happen. System will remain as it is. But if you check here, so this is going low, but nothing is happening. After this, there is a positive, right? Then this code will get triggered. The scenario which you are talking about is actually this. This is a negative edge triggered.
Yes, sir, got it.
Right? In this case, it will only look for a negative edge. At that time, this will happen. Okay. Here. Okay. Let's move to, let's see what is next. Okay, yeah, tricky question. What is the final value of A? Okay, so initial block, I mean, when is the initial block executed? For example, I have a code which is having a always block, initial block, right? So at what time initial block start getting executed? Time 0, time 5, time 10, time 15, time units. At what time initial block will trigger basically?
Time 0.
Sir, at zero.
Time 0.
Yes. As per our Verilog LRM, initial blocks will start executing from 0 nanosecond. That is, okay. Now in this code, we have a module test, we have a register A, and there is one initial block which is assigning this A to 0. And there is a second initial block which is assigning A to 1. Now, question here is, LRM says that initial block, it means initial block will start from 0 means all initial block, right? Each and every initial block in the entire module will be start executing parallelly at 0 nanosecond. Now, what is the value of in this case? I mean, if I print A, whether I will get 0, whether I will get 1 or X, what is the value I will get?
0.
Let's
In active region,
maybe different.
what I will get?
Initially, it will get 0.
Initially, it will get 0.
After some time period, you will get the 1.
Okay, one is saying
Only
that
0, sir.
Initial, it will be 0. After some time, it will be 1. Okay, the other answer I can here is
Only 0, sir.
always 0.
Excuse me, sir.
Yes.
So
Always 0.
initially the value is 0, but at the end of the clock, this value goes to 1.
Okay, actually value is 0, but end of clock.
Okay,
will
okay. Race
become-
condition, sir. Hello.
Raise condition. What do you mean by raise condition?
Actually, it cannot decide what I have to in blocking assignment. It will execute race condition due to it cannot decide what will be you have to put print.
Okay. So what print I will get? I mean, my print will be I cannot decide, or
Yes, sir.
it's a raise condition. What will be the print? I mean,
Maybe
I
that
cannot
depends
decide,
on the
sir.
simulator, sir.
X,
Maybe
X,
that
sir.
depends on the simulator.
Sir, so basically the initial block always starts at 0 times. So like it will print just the default value of A, because if you have initial A equal to 0 and if you have again initial A equal to 1, it prints what the simulator has. So it will be a default value.
in previous slide we discussed that the default value of register is X. We can say that initially it's having X. Now
Yes,
what? So what dollar display I will get? So what answer I was like heard is it depends on simulator, and one answer is X. Will there be any simulation error that my code will say there is an error in your code at line number 454?
No, yes, we will
Okay,
have a
there
simulation
will be a simulation error.
like if you have initial A equal to 0, then after if we can put like #10 or after some delay, if you put initial A equal to 1, maybe we might not get an error. But because initial statements generally run at 0 simulation time, so we need to have a delay before initializing the next one.
Okay, so you are saying that to resolve this simulation error, we need a delay.
Yes.
Sir,
Okay, so these are all the answers. Okay, any other answer?
sir, it is a race condition. Still, we will get answer as a 0.
still we will get answer as what?
0, 0, sir.
0 or 1 depending on the simulator.
Okay, 0 and okay, 0 or 1 depends. Okay, okay, let's discuss this. Now I'm marking this initial as a T1. Okay, I'm naming this as T1, naming this as T2. So as per our LRM, initial block will start executing at time T0. Okay, so the initial value is X. Now, if initial value is X, for example, so these two cannot run in parallel, right? I mean, either T1 will win or T2 will win. So in first example, let's see that T1 wins and T1 executed first. So if T1 is executing first, so T1 will assign its value, that is A equals to 0, right? If T1 wins, T1 will assign 0 to A. Now, after T1, T2 will execute, T2 will assign A into 1. So if we put a display, we will get 1 because T2 assigned A to 1 last. This A is having 1. In this case, we got a 1. But because still we don't know, right? We assumed that T1 is executed first. But now suppose T2 executed first. In this case, since T2 executed first, A is assigned to 1 is assigned to A. And after that, it's done for T1 to assign 0 to A. So we get a as 0. The answer which mentioned about it depends on simulator. Because it cannot, because it is not written anywhere that T1 will be executed first or T2. It can happen that in one simulation, this scenario is happening, and in another simulation, this scenario is happening. But we will get either 1 or 0, but we don't know. But there will be no X because assignments are happening. If you try with A simulator, it might give you 1. If you try with B simulator, it might give you a 0. So the answer in the interview will be that since there is a race condition, we are not going to get any simulation error in this case. Your simulator will give you the value. But sir, there is a race condition here, and simulator might give priority to T1. Then in that case, we will get 1. If it prioritize T2, then in that case, we will get a 0. Any questions?
Sir, can you explain what is meant by race condition?
So race condition means like this is a race, right? You don't know what is you are going to get at the output. So race condition means you have a race that you don't know whether this is going to be a, I mean, nobody can guarantee you. Cannot give one answer that because both scenarios can happen. So this is the race.
Hello, sir.
Because this question is going to be a part of your interview for sure. Okay, I think it's clear for all. Okay, so let's talk about equality operators, right? So how many equality operators do we have in Verilog? One is this one, other is this one, then we have triple equal to, we have this one, right? So anyone knows, I mean, let me jump.
अभी बीच में एक जगह नाश्ता कर लिया, सुबह का खाना खाया ही नहीं, इधर से वो जो बताया ना तेरे को आहार क्या कौन सा नाम?
Okay, can you mute? Okay, so we have these equality operators in our Verilog, right? So anyone knows what is the difference between these two, these four, or maybe mainly these two? And why we needed this operator when we had this operator already? So
generally a two equal sign, so it has like condition like true, false, and unknown, but that three equal sign will generally give either true or false. So that is the reason we have 3.
Okay. And in what cases it is going to give unknown? Okay, let's talk about that.
If the
In
register
the case
value
of
is
high
register
impedance,
value is high impedance.
Yeah. So if we look at this code, right? So in this case, so this is called as equality operator. This is called as case equality operator, right? This is more sensitive, this case equality operator. So the equality operator will check each and every bit of 2 operands. So A and B are called as operands, and this is called as operator. Okay. So this is going to compare each and every bit, but as soon as it observes the X or Z in any of the operands, any of the operands means whether into A or B, right? It will stop there and will return you X. So let's see in this case. A is 1X. Let's write it here. Is 1X and this is 1X. So we might. Okay, I think. Okay. So we might get confused, right? Because both are same. So if somebody asks me whether.
Yeah, Madhav just removed that person.
Yes, sir. I have removed him, sir.
Okay. So we might get confused, right? Because this equality operator is asking me whether this is equal, and it seems to be equal, right? So one bit is same. It will compare 1 with 1. Okay, it matched. But the moment it sees X, it will not even compare it. The moment it sees the X, you are going to get a X. And if condition means, okay, so let me ask this question, right? So what display I will get if I execute this piece of code? What display I will get?
Display 2.
Display 2. Okay, and what I will get in this display?
Display 3.
Display
3.
Okay, and what I will get here?
X.
Any guess?
X will be displayed.
Display 2. Okay. Why not display 3 and why display 2?
It is not true or false, so it is like unknown. So it's none of it. So it won't display either nothing 2 or 3. It won't display anything.
Okay, it will. Okay, so this code will not print anything basically.
Yes.
Okay. It is going to display 3 because it checks whether this is true. If this is not true, it will assume it as false.
Okay.
Yes. If this is true, it will assume it as false, and that is why you're going to display 3. In this case, it started checking second value, and it checked, okay, there is X. I'm not going to compare second bit. It return you X, and you will get a mismatch here. And this is also a tricky question, this one. I mean, this is also a tricky question because the person who said, right, because it's a X. We generally say that, okay, X is unknown. It might print display 2, it might print display 3, or it will not print anything, but it will actually print 3. In this case, we are going to get a mismatch. Now, so that is why we in Verilog announced and give us this case equality operator, which has the capability to compare X and Z as well. In this case, we are again having a 1X equals to 1X. Now, it compared first bit, that is 1 with 1, okay, matched. It has the capability to compare X with X. it compared, okay, this is matching. Okay, this is a perfect match. Is this clear?
Hey, what समझाई ना समझे समझे.
Sir, can you explain
Sir,
the
can you
equality operator for this x if x is display the 3? How is it possible? If maybe x will be true, like for example, it's 1, then it display 2, right?
Yeah, but it's, well, see, in this case, right? In this case, what we are going to get, according to whether we are going to get a match or mismatch. In this case, when value is 1x, and I'm using equality operator equals to b. So what am I going to get? Matched or mismatched?
This condition, yeah, this condition will return the x. So it will not go in the mismatch or match.
It goes to mismatched.
It's going to display the mismatch.
Yes. You can try this code. I mean, very basic code, right? You can try in your simulator. You are going to get a mismatch.
Okay, yeah, thank you, sir.
Yeah, no problem. But in this case, we are going to get a match because this is a perfect match. If this is clear, I'm going to ask some questions here. Any questions, please ask.
Sir, how 1x is matched to 1x? It can be means different bit.
No, that is what this case equality operator is doing, right? What it compares 1 with 1. Okay, matching. It compares x with this second bit of this second bit. It matches. This is what this case equality operator. It doesn't look it this way that okay, x can be 0 or 1, this x can be 0 and 1. That is how this works. Otherwise, this is going to give me multiple options, right? Because this can be 1 0, this can be 1 1. This is how a case equality operator works. So was the confusion in this case? Operator says, okay, this is x. So should I consider this x as 1 or 0? That is why it returns x. And Verilog introduced one new operator, that is case equality operator for such scenarios. Now let me ask a few questions here.
Hello, sir.
Excuse me, sir.
Yes. Yes, go ahead.
Sir, in the case equality operator, sir, here you consider A equals 2 tick B1x, sir, and B equals to 2 tick 1 BX. Sorry,
Wait,
1x.
wait. What is A?
If B is equals to 2 tick, sir, if I change the value of the B, that is 2 tick B1Z. So at this situation, will it display mismatch?
So you are saying this? Are you saying this scenario?
Yeah, yes, sir.
Okay, and you are checking this?
Yes, sir.
Okay, so can anyone help me answering this question? So what are you going to get? Matched or mismatched, guys?
Mismatched.
Mismatch.
Yes, because it checked first bit, 1 with 1, but second bit is not matching. So we're going to get a mismatch here. And what are we going to get in this case?
Mismatch.
I have changed the case in
Mismatch.
mismatch because you cannot check x with z. Yes.
Sir, it means in the equality operator, it will check the means compare the bit to bit operation.
Yes, bit to bit. That is, first bit is x, first bit is z. So it mismatched here itself. It will not go to the second bit. Bit by bit comparison will happen.
Okay, sir.
Not the over value, not the overall value. You might wonder that it compares no, bit by bit value. Okay.
Yeah,
Sir,
yes, sir.
hello.
Yes.
Sir, in comparison, the circuit which is involved is XOR gate only, right? Mostly, like in when we go in hardware level.
XNOR.
That depends, right? I mean, it can implement into some other thing as well.
Then how the don't care condition will be compared with like how two don't care conditions can be compared, sir? I'm not able to get into hardware level.
Yeah. So let me. I think these operators are not synthesizable. What I remember, these operators are not synthesizable because you cannot say. Yeah.
So without synthesizable only, they will be comparing the like. There is another circuit, sir.
This is all simulation, right? Simulation doesn't need to be synthesizable. This is simulation environment. Comparison is happening in simulation. Simulation is different from synthesis.
Okay.
All the things in
this is just a behavior model, right?
Yeah, I mean, so for example, all the things. For example, you have classes in system Verilog, right? But classes are not synthesizable.
Yes, sir.
So this is simulation environment. Everything which is declared or which is provided by LRM can be simulated, but not everything is supported as cannot be synthesized basically. So we are working on at simulation level. Once simulation is done, so simulation RTL is generally okay. Let's talk about this, right? So in our verification, we have a RTL, right? And we have a verification environment, right? So this RTL has to be synthesizable. But this verification environment, which we generally call as need not to be synthesizable. It can be or it cannot be. And you synthesize only RTL. You don't synthesize a test bench. Because RTL is going to what you are going to get at the chip level. We are creating a test bench to verify this. All these operators, right, we use in test bench. Whether, I mean, just to make sure that there is no value of X, unexpected value of X we are getting in RTL. Because if we have used this operator, in equality operator in test bench, so it's never going to return me that you have got X. It always return me a true or false. Just to check and make sure that my RTL is not returning any signal as X or Z. We use this in our test bench comparison in scoreboard, in checkers, right? So these are not synthesizable.
Oh, okay, sir. Thank you.
No problem. Yeah. Any questions on this previous slide that we discussed? Okay. No questions?
Sir?
Yes.
So that means that RTL can give X and Z values, right?
It can give. I mean, in some scenarios, like you have a wire, right? And you are assigning two different values to the wire at same time. So it can give, but it should not give. I mean, that is why we are doing a verification, right? To identify such scenarios, and if there are any such scenarios so that we can rectify them.
Okay.
Right. Okay. I think that's all from my side for today.
Sir, you were going to ask some questions.
Actually, I was asking in the this equality operator, right? But I think when someone else asks that question, I think it is clear for all, is what I feel.
Yes. So anyone have any doubt
these
now?
questions are very, logical, right? I mean, and you are going to see these questions in your interview for sure.
Yeah, exactly. These are interview questions mainly, right? So anyone have any doubt now? Any query or any doubt?
No.
So when do we have the next class? Like, do we have like every week we have a class like this?
No. This is the free master class. It is 1 or 2 classes in a month. So if you want to go for complete course, then go for the complete course. This is like demo free classes. It will be only 1 or 2 class per month.
Okay, like this is similar to the premium verification RTL course, right?
Yeah. It is part of that.
Okay.
Course 500-600 hours.
Sir, what simulators can we get access if we take that course?
Vivado, Model Sim and Costa Sim, 3 software we are using.
Okay.
So anyone have any doubt now? Okay, then we are ending this meeting. If anyone want to
More
give the
details,
feedback of
guys.
sir,
Yeah, no problem.
if anyone want to give the feedback of sir, they can give. Like if anything there is room for the improvement or anything, you can tell us.
Yeah, guys, any feedback for the session? Much appreciated.
Yeah, you can personally pinch me also, or you can write on the group. That is also fine.
Excuse me, sir.
Great session, sir. Great session.
सर ये पीपीटी मिल जाएगी हेलो
आप पीपीटी दे देंगे ग्रुप पे देंगे एनरोल्ड वाले स्टूडेंट्स को मिलेगा लाइक नॉट फॉर ऑल
Okay.
Sir, how to enroll, sir, for your course?
You can WhatsApp me. I am the admin of the group. You can enroll me.
Sir, do we have like once we enroll to the course, do we have like recorded lectures or like we have live classes?
Both the things are.
Fee is how much, sir?
Just pinch me on the WhatsApp. If you have any doubt related to the class, you can ask me. Otherwise, sir, you can leave it so that I can interact with them. It will be boring for you. Anyone have any doubt related to the class, then you can ask. Otherwise, we can just wait for 5 minutes. So I will answer those queries.
Excuse me, sir.
Yeah, Sonali.
Sir, could you show the PPT once?
Okay.
It is gone now. It's gone now. Yeah. So, anyone have any doubt related to the course now?
Yes,
Related
Sonali,
to the
you were
course
having
or-
some.
Yes, sir.
Sonali.
Yeah, sir, in the last slide, sir, that equality operators. Sir,
Yes.
yeah, sir, as sir in the Verilog code, so there is a case X and case Z equality, also equality there. So, sir, that equality operator is also applicable in the system Verilog.
No, I mean case X and case Z is a different thing, right? These are operators. Case X, case X, case Z are different thing. This is a different concept itself.
Okay.
So they behave in a similar manner, but they are different. Like you use case like this, right? I mean, cases are different. So you say that when it is 1, you do this. When 2 is this, when you do this, and then you replace with this case X or case Z. But and your question is, can we use these in system Verilog?
Yeah, yes, sir.
Yeah, we can definitely use. I mean, system Verilog is a backward compatible. So whatever is there in Verilog, you can definitely use in system Verilog.
Okay.
Yes.
Okay, sir. Yes, sir.
Yeah.
Any other doubt,
Guys,
anyone? Any other doubt related to the class?
क्लास बहुत अच्छा था सर
Okay, बढ़िया.
Thank you, sir.
थैंक यू
Okay, thank you.
Thank you, sir.
Thank you, sir. Sir, what are the
Okay.
things that we know about when we say about the decision and verification engineer? What are the languages that you have to know, like Verilog or System Verilog now currently
Verilog,
they are
system
using
Verilog,
in
UVM
industry
protocols. Actually,
protocols means
we
AXI,
have
AMA
mentioned,
protocols. Okay, sir.
on the website. You can check the syllabus on the website once. There are a lot of
Okay,
things.
sir. Okay.
Even scripting language, Linux, those are also needed.
Okay, sir. Okay, okay.
Only Verilog is not sufficient, obviously.
Okay, sir. But sir, UVM is not compatible now. System Verilog is a compatible of Verilog. Sir, System Verilog is a backward compatible of Verilog only, no, sir. But UVM?
UVM is obviously above version of that system Verilog. Nowadays,
Okay, sir. Okay.
it is universal. All the companies are using same like compatible system. That is methodology, not a language. So just
Yes, sir. Okay.
just wait for those classes for the UVM. We will arrange the UVM demo classes out. So don't worry. By different faculties. Don't worry.
Okay, sir. Okay, sir. Thank you so much, sir. Okay.
Yeah. So don't worry. What do you do exactly? What, Prem? Okay, thank you. Anyone have any doubt? Ready? Okay, then we are ending this meeting. Thank you.